So same kind of question. This one is saying the ones digit. So ones digit means the last digit, right? Like if you have 73,286, it means that digit. It's the last digit for 2 to the 45th power. So now we know 2 to the 45th is way too big on your calculator. If you did 2 to the 45th, it would not be able to show you all the digits. You could not see the ones digit. You can't get down there. So instead, we just look for the pattern. Let's try it out. 2 to the 1 is just 2. 2 to the 2, 2 times 2, that's just 4. 2 to the 3, 2 times 2 times 2 is 8. 2 to the 4, I'll just write the answer 16. 2 to the 5th, 32. 64. 128. 256. I'm just doing a few of these. See if we can see the pattern. 2 to the 10,000. That's probably enough. Just use your calculator. I'm just multiplying by another 2 every time. All right, so far so good. So I just did a bunch of 2 powers. And of course, we want to know 2 to the 45th is blah, 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 blah. And what's the last digit? The ones digit for 2 to the 45th. What do you guys think?
I see a pattern of it going to the one digit being 2, 4, 8, 6, and then repeats 2, 4, 8, 6, and then so on, 2, 4, 8, 6.
Very good. Good observation. Yeah, everybody's seeing that cycle that Martine is pointing out. 2486, 2486, starting it again here. 24. Yeah, it's just cycling 2486, 2486, 2486, isn't it? So this time there's a pattern of a cycle of 4. Last time it was just 2 numbers. This time it's 4 numbers in a repeating cycle. Okay, great, excellent. So now how can we use that information to go all the way out to 2 to the 45th power and find the ones digit?
I mean, I feel like you could probably, since we know that 5 divides evenly into 45, we could probably do something with that, and then we could probably get like 9. And if you notice that if you divide it by 5 and get 9 for the answer, they'll always
Martine,
end
why are
with
you
2.
talking about 5? But why would you divide it by 5?
I'm kind of just looking at the exponents. So like 2 to the 5th, the one number is 2, and then I don't know. I'm kind of trying to do a best guess type of thing.
I like what you're saying, but I don't think 5 is the right number. Remember what we did last homework when we have repeating cycles, right? Like in the last homework, we what if I gave you a decimal? I said the decimal is 0.2486. Remember the repeating pattern? 2486, 2486. And I said go all the way out and tell me what is the 45th digit. Remember those from last time? Let's just turn it into a forever repeating decimal. So what if I gave you guys this kind of question? Think with me on this. We did this earlier. I think it was the last assignment, right? We had those decimals that repeated forever, and we tried to go way down the line and find a certain digit. That's kind of what this is like, right? 2486, 2486, etc. forever. Like a decimal that repeats forever, 2486, 2486, 2486 forever. How could you go all the way down and find the 45th digit in that string?
You could divide 45 by 4.
Yeah. That's what we did in the last homework. I think it was just yesterday's homework, wasn't it? Or Monday's homework. Yeah, we just divided by 4 because you're trying to find out how many full cycles of 4. Because every time you do a cycle of 4, you start over again, don't you? Right? 2, 4, 8, 6, start over again. 2, 4, 8, 6, start over again. 2, 4, 8, 6, right? So you have to divide by 4. So we go out here and we go, okay. So I'm going to take 4 into 45. So use your calculator. 45 divided by 4. I think it'll tell you like 10.2. No, 11. 11.25. Is that what it is? I think it's 11.25. So you go, oh, 11. So you grab this 11, put the 11 up there, multiply, get 44. Remainder 1. Remember how we would do like that long dividing and we would get the remainder? And we would say, okay, so what does that mean? That means that there's 11 full cycles of 4 digits. Right? 11 full cycles of 4 digits is 44 digits. Then 1 more remaining to get to the 45th digit. Right? 1 more remaining to get to the 45th digit. So that means what's my answer then?
Two.
Exactly. Does everybody see that? Right? Everybody get that? Because there's 1 more remaining. So we go 1 more into the last group. Right? We go 1 more into the last group. Right? So for the very last group, the 2, 4, 8, 6, right? Because it's 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. There's 11 full cycles of that 2, 4, 8, 6 stuff, and then 1 more into the last group. So that, boom, 1 more into the last group, you'll end with a 2. Boom, we're done. That must be the answer. The ones digit for 2 to the 45th power has got to be a 2. We can see it by the pattern. 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6 forever. We know there's 11 full cycles of that, which is 44. And then 1 more to hit the 45th digit, go 1 more into the last group, it's got to be a 2. So it's exactly like the repeating decimal stuff we did before. It's just, again, it's that idea of a repeating cycle. And how do you go way down the line in a repeating cycle, 45 places down the line in a repeating cycle? You've got to divide. You got to see how many full groups of 4, 11 full groups of 4, and 1 remaining. The remainder is always the key because you go, that means how many you have remaining in the last cycle. 1 more into the last cycle. The first digit is a 2. That's it. It's got to end at a 2.